Welcome to this explainer. Look, I'm a veteran Cambridge chief examiner, and today I'm pulling back the curtain. I'm taking you right here to my side of the marking desk for an absolute insider's look at exactly what we see when we grade your papers. Have you ever wondered what actually separates a solid, okay B grade from a truly flawless A star in Cambridge AS and A-level mathematics? Well, let me tell you, sitting here looking at thousands of scripts on the Cambridge portal, it is absolutely not just about raw calculation power. It's about understanding the precise grading architecture. Today, we're using a very specific and honestly heavily misunderstood topic, numerical solution of equations, specifically locating roots by sign change, to decode exactly what examiners are actively hunting for. We're going to look at the exact frameworks, the specific terminology you need to use, and the hidden traps that we highlight in the principal examiner reports year after year.
Okay, let's dive into this. This structured syllabus right here is your blueprint to outsmart the marking desk. We'll cover 1. The examiner's perspective. 2. The theoretical architecture. 3. The 5-step procedural framework. 4. Critical problem-solving strategies. And 5. Avoiding top examiner mistakes.
Let's start with Section 1, the examiner's perspective. This is the reality of the high-stakes exam environment.
The stakes in the 9709 exams are incredibly high. When your script loads onto my digital screen, I have a very limited amount of time to assess your mathematical logic, and success here comes down to understanding the criteria we use to award marks. When you're staring down a high-tariff multi-part question on locating roots by sign change, you need to know that examiners aren't just hunting for your final numerical answer. We are looking for logical, structured reasoning. Now take a look at this direct quote from the Cambridge Principal Examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. This is literally a game changer. The most successful candidates out there, they don't treat locating roots by sign change as some isolated floating island of math. They weave their answers together with other syllabus areas. Maybe they connect the numerical solution back to the graphical representation of a function, or they link the algebraic properties to coordinate geometry. As an examiner, I'm actively looking to reward you for showing that you understand how the entire mathematical ecosystem fits together.
And this brilliantly illustrates what I call the ultimate safety net, the method mark strategy. I honestly cannot emphasize this enough to my students. Marks are awarded strictly for demonstrating the correct problem-solving process and showing logical reasoning even if your final numerical answer is completely wrong. Let's imagine a candidate, let's call him Alex. Alex is testing the interval for a sign change. He sets up his function beautifully, he plugs in the upper and lower bounds exactly as he should, but he makes a tiny, silly arithmetic error right at the very end. So his final answer is wrong. Does Alex score a 0 for that question? Absolutely not. The assessment framework heavily rewards Alex's structured reasoning. The process itself is what secures the bulk of his grade. We as examiners want to see your brain working on the page.
Moving right along to Section 2, the theoretical architecture.
Okay, so here's the thing. Examiners are actively looking to see that you understand the why behind the math. Why does the sign change indicate a root? Well, it's specifically because for a continuous function, if the curve is below the x-axis at point A and it's above the x-axis at point B, it absolutely mathematically must have crossed the axis in between those 2 points. The golden rule you need to remember here is that analytical depth is always greater than superficial breadth. You really can't just memorize a surface-level formula, dump a massive unorganized paragraph of facts onto the page, and hope for the best. The conceptual framework demands precise definitions, clear causal relationships, and evidence-based reasoning. When you evaluate f of x at 2 different points and you note the signs are different, you must explicitly state the causal relationship. You have to say, because the signs change and the function is continuous, a root lies in this interval. That exact evidence-based reasoning is what elevates your script from an average middle-of-the-pack grade to an exceptional A-star tier response.
Let's move to Section 3, the 5-step procedural framework, and see how this actually builds into a repeatable process.
All right, I want you to lock this tangible technical methodology into your mind right now. Think of the memory hack acronym, DESEP, DSEP. First, deconstruct the question. What exactly is the core command word asking you to do? Second, extract relevant data. Pull out the specific function and the numerical bounds you were given. Third, select your analytical framework. In this scenario, it's locating roots by sign change. Fourth, execute with clear notation. Now, this is absolutely crucial. This means explicitly writing out f of a equals whatever your result is and f of b equals whatever your result is. Do not skip steps here. Show me the positive and the negative. Finally, step 5, present with correct terminology. You literally need to write the words sign change and root lies between.
If you deploy this DCEP framework on exam day, you leave me, the examiner, absolutely no room to dock your marks. It's a flawless string of logic.
Let's shift gears to Section 4, Critical Problem-Solving Strategies. This is about higher-order thinking.
To hit that A-star, we need to address the higher-order assessment objectives. Now, an average candidate engages in what I call standard problem solving. They just systematically crunch the numbers, find a numerical answer, and rapidly move on to the next page. But top-scoring candidates, they use evaluative thinking. They identify the given information, they break it into logical steps, they solve it systematically, and then, and this is the critical part, they check for reasonableness and make justified, evidence-based recommendations. Imagine your sign change calculation tells you a root is somewhere completely illogical based on the earlier parts of the graph you drew. A standard candidate ignores that and moves on. An evaluative thinker stops, catches that contradiction, evaluates the alternatives, and justifies every decision with mathematical evidence. That's the difference between just finding the answer and actually understanding the problem.
Finally, we reach Section 5, Avoiding Top Examiner Mistakes. Let's do a little live audit of where things go wrong.
So, the crucial point is knowing what not to do. I am pulling back the curtain on the principal examiner reports to show you exactly where thousands of candidates drop crucial marks every single year. You do not want to fall into these top 3 pitfalls. Number 1, answers are too vague. When locating roots, if you just vaguely write down 2 numbers and scribble root here, that is nowhere near specific enough. Examiners want specific details. We need to see the calculation. We need to see the positive and negative results explicitly shown. Number 2, ignoring format and presentation. Look, mathematics is a language. If your notation is messy or you randomly drop your brackets mid-calculation, I simply cannot follow your logical string, and you will lose those precious method marks. Number 3, answers are not specific to the provided context. You can't just drop in a textbook definition. You have to draw evidence-based conclusions that directly answer the exact prompt in front of you. We are rigorously checking your terminology against the specific contextual evidence of the question.
I want to hit you with a direct question right now, and I want you to answer honestly. Are you showing enough working? Think back to our method mark strategy. Omitting your working steps is an immediate, devastating penalty on the marking desk. Even if your final answer is 100% correct, if you jump from the raw equation straight to the conclusion without showing those sign change evaluations in between, my hands are tied. I cannot legally award you the marks for the process. Don't let your hard work go to waste because you rushed the documentation. Master the framework. Secure the A-star. By deploying the DCEP framework, by thinking evaluatively instead of just crunching numbers, and by dodging those common pitfalls, you completely align yourself with the marking desk. The next time you sit down to solve a past paper, ask yourself, are you just finding the root, or are you actively proving your mathematical logic to the invisible examiner reading your script? Thank you for joining me for this explainer. Before you go, let's secure your academic trajectory. Hit the subscribe button for Ace the Exams, that's @AceExams, right now and turn on all notifications. This is your direct channel to outsmart the marking desk. Leave a comment below stating your subject, your qualification level, and your current target grade. Keep your reasoning structured, and I will see you next time.